Hello! This video will discuss how Truda Environmental Solutions High-Definition Stream Survey Technique, also known as HDSS, will provide you with the data you need to get better results from your waterway project. This video uses actual data from 2 Coosa River Bypass HDSS surveys we did that documented the relicensing information required by the Federal Energy Regulatory Commission, also known as FERC. A high-definition stream survey is the continuous collection of video and sensory data over multiple miles of waterway. What does this mean? We have cameras pointing to both the left and right stream banks, recording bank and riparian condition, infrastructure, and point and non-point sources of pollution. Our forward camera records habitat types, such as pool riffle run, large woody debris, and other requested information. Our underwater camera allows us to assess the stream bed for substrate type, embeddedness, aquatic vegetation, and other visible underwater features when conditions allow. Our water quality sensor records numerous water quality parameters at 1-second intervals. If turbidity and depth are not conducive to underwater video, our side scan sonar will georeference numerous channel characteristics throughout an entire reach. In addition to longitudinal depth measurements recorded every second, we can collect cross-sectional bathymetric measurements at any requested locations. We use an acoustic Doppler current profiler to measure discharge for more detailed bathymetric projects. We can easily accommodate the growing demand for eDNA as well by collecting grab samples as frequently as needed. Most importantly, the latest GPS technology ties all this information together at an exact time, location, and surface water elevation. This allows us to deliver extensive GIS data that can be used by itself or with other layers of GIS information. Depending on the size of the stream or river, HDSS can be deployed using different platforms to rapidly record all of the data and video you need in a single survey. Documenting everything in the stream corridor allows the same HDSS data to be used for multiple permitting requirements, including FERC relicensing, Corps of Engineer permitting, MS4 stormwater, and others. The Coosa Bypass HDSS project was driven by FERC compliance requirements and involved 2 different surveys in order to document changes. The first HDSS was completed in 2012, which recorded baseline conditions in the bypass prior to the implementation of the 200 CFS environmental flows. The second HDSS was completed in 2018 and provides the ability to see where and how the in-stream habitat has changed. The Coosa River is large enough to require a dual-track HDSS to ensure adequate coverage across the channel. This was achieved using 2 identically rigged boats concurrently for each phase. GIS post-processing allowed us to align data from each stream bank into a center line, allowing for easier to understand data. Stream view video production is the first step of the HDSS process after fieldwork. Regardless of where you are right now, you are seeing the actual conditions from August 14, 2018 in the Coosa Bypass without having to leave the office. Rather than relying solely on an assessment score sheet filled out by someone else, you and your management team are now able to virtually survey the river to see actual field conditions. After it is collected, field data is fed into the database where it gets processed to fulfill the requirements of a project. Truda has developed HDSS video coding software that can quickly analyze and categorize numerous data parameters, all of which are linked to the exact GPS location where the data was collected. Georeferencing such large volumes of data reveals trends and information that would have never been apparent using traditional site-based sampling methods. For this survey, bank condition and habitat types were mapped out and delivered for monitoring purposes. After the video is converted into data, GIS layers are created for highly informative results. These 2 maps show color-coded depth and habitat types throughout the Coosa Bypass. Users are now able to zoom into any area for better detail and can also watch video associated with the color coding on these maps. The map on the left shows color-coded substrate types documented throughout the survey area. In addition to documenting continuous variables throughout the survey area, point data such as large woody debris, pipe outfalls, boat ramps, fish barriers, in-stream vegetation, or others are recorded as point features. One application of the HDSS data was to combine variables into habitat suitability analysis for important mussel species in the area. By combining water depth, surface water velocity, and bank condition data, we are able to determine the most likely locations to find mussels, how the habitat changed in response to the environmental flow restoration, and highlight the areas with the highest potential for mussel reintroduction. Alabama Power Company has 4 community sampling stations in the Coosa bypass that are regularly sampled with years of historical data. By comparing the HDSS data from within those stations, we can now see habitat trends that influence the documented species assemblages. The following series of maps highlight how effective HDSS is at measuring project impacts over time. Here you can see the changes to the left bank condition before and after the implemented 200 CFS environmental flows. Here you can see how depth measurements changed during the implemented environmental flows. Here you can see how habitat types changed in response to the environmental flows. In addition to comparing GIS data between 2012 and 2018, it's also easy and useful to compare video of the survey area to make it even easier to understand. For example, in the right 2 images, the increased flow scoured debris from this riffle complex. During the HDSS in 2018, APC requested cross-sections to be surveyed for TMDL modeling as well as to comparing with historical depth data. Each transect involved precise measurements of the river's width and depth at 12 transects in the survey area. HDSS allows the continuous longitudinal data to be collected in conjunction with the normally time-consuming cross-sectional transect surveys. This chart shows the 12 cross-section profiles in relation to the surface water elevation. Due to downstream hydropower generation, flow direction changed, and the surface water elevation actually started rising as we were moving downstream. In closing, HDSS is a better waterway assessment technique for the following reasons. We can collect more data using fewer people in a shorter period of time compared to traditional assessment methods. This leads to lower costs. Continuous data is better than site-based data because there are no extrapolations and you are able to see everything. These and other factors combine to make HDSS a better data solution for your permitting, planning, and mitigation projects. Thank you. Again, we are Truda Environmental Solutions, developers of the High Definition Stream Survey, bringing you more data at a higher quality at a lower cost. Contact us at info@trudasolutions.com or visit our website, trudasolutions.com.